Hello, I'm Mark from Productive Computing and Productive Computing University. Thanks for joining us in this lesson. Wanted to share with you a lesson excerpt from a larger course called AI Essentials for FileMaker Developers. This course is especially geared for those who are brand new to the world of AI and you are already finding yourself confused, overwhelmed, and perhaps even a little reluctant to get started. Our strategy here is to teach you AI integration using both the traditional methods, whereby we directly connect to providers like OpenAI, as well as teaching you the new built-in scripts and functions that Claris provides us to integrate AI out of the box. So you can expect to learn everything you need to know in order to immediately integrate AI within your own solutions, including lessons for summarizing data, providing sentiment analysis, working with memory, storing two-way conversations and their context, DDL structure for specific JSON return values, and more. Then we have a dedicated section of the course where we learn state-of-the-art AI using Google Gemini and its exciting multi-modal capabilities. You'll learn how to analyze pictures for a complete and detailed analysis, and you'll be able to take audio and have that transcribed and turned into text and immediately then translated to another language, all in a single call. You'll learn how to conduct live searches within your queries, providing you with up-to-the-minute accurate data automatically woven into your results. Okay, now on to the free lesson from the course. In this lesson, we talk about AI terminology. So what I'd like to do is paint a terminology landscape where we go from the broadest terminology all the way to the most defined terminology as it relates to artificial intelligence. So on the outer layer, the biggest, broadest category is artificial intelligence itself, AI. As the broadest category, it encompasses all technologies that enable machines to perform tasks that typically require human intelligence. Our next level is machine learning, which is a subset of AI, focusing on algorithms that allow computers to learn from data and improve over time without being explicitly programmed. It's the practice of training algorithms to recognize patterns and make decisions from data. The next level is something known as natural language processing, NLP. And it's a subfield of machine learning that deals specifically with the interaction between computers and human language. So in this layer now, we're honed in on specific machine learning related to human language. Our next level is something known as large language models, LLM. These models are a specific type of natural language processing models trained on vast amounts of text data to perform various language-related tasks. These models vary from provider to provider based on size and scope, as well as specialty. Our next level is something known as GPT, which is short for Generative Pre-trained Transformer, which is a specific type of LLM developed by OpenAI and designed for generating human-like text-based or input prompts. So it takes that LLM that was trained on a large, massive amount of text data oriented around language and defines it in a way that allows human-like text-based input and text-based output, or requests and responses. And finally, ChatGPT is a specific product and application built using the GPT, Generative Pre-trained Transformer, and its focus is on conversational interactions. It stores the history of your conversation. It can store the memory, so it remembers things over time based on your preferences. And there's a lot of other new and exciting features about ChatGPT. ChatGPT itself is an application that's designed for regular people, not necessarily developers. And it's distinct and different than working with the OpenAI API. The API has direct access to the GPT models, whereas ChatGPT is a separate and distinct application itself, something you can download on your computer, install on a remote device, or even work with on a website. Next, let's talk about some additional terminology as you work with AI. We have tokens. A token is a basic unit of measure, measuring words or subwords, and this is used by AI models for processing. It measures the amount of text you send to the API, as well as the amount of text received. These are also known as input and output tokens. We'll have a dedicated section talking about tokens and how tokens derive price of usage when it comes to OpenAI. Keep in mind that every provider has their own pricing scheme and way of determining the amount of tokens used. Next, we have prompt and prompt engineering. A prompt is much like you'd see if a dialogue was asking you a question. In this case, it's us asking the API a question. So a prompt can be thought of as a request. It can also be thought of as a question. It's not always necessarily a question. You can make a statement and still get a response. All of that boils down to a common term called prompt. And prompt engineering is the art of crafting specific inputs to guide AI models and generating desired outputs. You'll find a dedicated lesson on prompt engineering later in the course. Then we have the API key, which is a unique code used to authenticate and access an API for integrating external services. It's your security method for an API to know that it's you connecting to it. This is common in the world of APIs, and you'll find it used here when working with AI providers as well. Next, we have something called a DDL, known as a Data Definition Language. These are SQL commands used to define and modify database structures like tables and fields. We'll see how this impacts our integration later on in the course. Next is a term called embeddings, which are numerical representations of text used to capture semantic meaning in comparisons or searches. We have a dedicated section in this course talking about embeddings and training data by converting text into vectors, which we'll talk about next. A vector are numerical arrays representing data, often used in AI to capture the meaning of text or other inputs. A word by itself doesn't mean much to an API. However, if that word is converted to numbers, known as vectors, then the AI understands its relationship and how that world works in the universe of language. By embedding your text and converting it to vectors, you then assemble a construct that your solution can understand the meaning behind words, allowing you to create finds that will find other records with likenesses that aren't necessarily exact, but relevant based on a certain order. And speaking of relevancy based on order, that's where the notion of cosine similarity comes into play, which is a measure of similarity between two vectors, indicating how close they are in terms of direction, often used in text comparison. So embeddings, vectors, and cosine similarity might seem a little fuzzy right now. It will make a lot more sense when we see it put to practical use with actual real-world use cases later in its own dedicated section when we talk about semantic search. So that takes care of the basic terminology. I'm sure other terms will pop up here and there, and we'll do our best to define them. So whether you're new to AI or looking to deepen your understanding, this course will help you take your FileMaker solutions to the next level, and we're excited to have you join us. If you are interested in this course, you may want to consider investing in the University Bundle, which gives you access to our entire course library for one yearly subscription price. So to learn more, you can find us at productivecomputinguniversity.com. Thanks again for joining us on this video, and we hope to see you in one of our courses, especially if you want to learn AI from the ground up as it works with Claris FileMaker Pro. Love to have you. See you there. Thanks for watching.